Hi everyone, Assalamualaikum. In this video, we are going to discuss example 4 under integration by trigonometric substitution. Now we look at the example for radical square root of a squared minus x squared, and we take x equals to a sine theta, right? Evaluate integration of x over bracket 4 minus x squared to the power of 3 over 2 dx using trigonometric substitution, right? Now, let me look at the complete solution. Okay, using trigonometric substitution, first step, we take x equals to 2 sine theta, right? Why we take x equals to 2 sine theta? Okay, from here, bracket 4 minus x squared to the power of 3 over 2, we can write equals to bracket square root of 4 minus x squared cube, right? And then constant 4 here, we can write 2 squared. And then minus x squared, square root, and then bracket cube, okay? And then since we have square root of constant squared minus x squared, okay? So now our constant equals to 2. Okay, our a now equals to 2. Okay, from integration by trigonometric substitution, if we have radical square root of a squared minus x squared, we need to take x equals to a sine theta. Alright, so now our a equals to 2. So that's why we take x equals to 2 sine theta. Because we have term containing square root of 2 squared minus x squared. Okay, when we write bracket 4 minus x squared to the power of 3 over 2, means that we can write into the form of radical, right? So we use this formula, okay? Alright, after that, we continue with step 2. Since for all trigonometric function, we have x squared. So step 2, we need to find x squared. So we just squaring on both sides from step 1. So we get x squared equals to 4 sine squared theta. And after that, step 3, we need to differentiate from step 1. Okay, we differentiate x with respect to theta. So we get dx over d theta. Okay, now we need to differentiate 2 sine theta. We still have constant 2 in front. And then when we differentiate sine theta over d theta, we get cos theta. So that's why we get this. And d theta here come from over d theta from left hand side. And we need to move to right hand side. So we get multiply by d theta because we want to write dx as a subject because we want to substitute into the given question here, right? And after that, step 4, we need to eliminate radical square root of 4 minus x squared. Okay, since bracket 4 minus x squared to the power of 3 over 2, we can write into the form of radical here. So we need to eliminate radical 4 minus x squared. Okay, and it is equals to 4 minus, we replace x squared equals to 4 sine squared theta, and then square root here. And after that, we have same constant 4 here, so we can factorize constant 4. And in bracket, we get 1 minus sine squared theta. Okay, so that when we expand, we will get back 4 minus 4 sine squared theta. Okay, and then it is equals to square root of 4. We can write 1 minus sine squared theta equals to cos squared theta from this identity. Alright? Alright, after that, we can simplify square root of 4 equals to 2, no more square root. And then square root of cos squared theta equals to cos theta. Alright? So from here, okay, we have term containing radical and no trigonometric function. Okay, and after we simplify using trigonometric identities, now we have no more radical but with trigonometric function. Alright? Alright, from the given question, since we have 4 minus x squared bracket to the power of 3 over 2, which is equivalent to square root of 4 minus x squared bracket cube. So, we can find square root of 4 minus x squared bracket cube first. Okay? It equals to radical square root of 4 minus x squared equals to 2 cos theta. And then we have cube here. Okay? 2 cube equals to 8. Okay, and then cos theta cube equals to cos cube theta. Okay. Alright, after that we substitute equation 1, step 1, 2, 3, 4, all of this into the given question. Okay, so therefore, from the given question, integration of x over bracket 4 minus x squared to the power of 3 over 2 dx, we can write integration of x over square root of 4 minus x squared bracket cube dx. Okay. Alright, and then we replace one by one. Okay. We replace x equals to 2 sin theta from step 1 here. Okay. We replace dx equals to 2 cos theta d theta from step 3 here. Okay. And we replace square root of 4 minus x squared bracket cube equals to 8 cos cube theta. Okay. So we replace one by one. Okay. Then we get this. Alright. From the previous slide, after we substitute step 1, 2, 3, and 4 into the given question here, we get all terms in variable theta and d theta. Okay, we get this. Okay. After that, we need to simplify. Okay. So after we simplify, we have 2 times 2 equals to 4 over 8 means half. We can move out constant half from integration sign. And then we can simplify cos theta and cos cube theta here. So we get denominator with cos squared theta. And we still have numerator sin theta. And then d theta. Okay. So now we have integration of trigo function. Okay. So to evaluate integration of trigo function, let us check from appendix. Okay, from table of integral in appendix. Okay, from here, there is no formula for integration of sin x over cos squared x dx. Okay, so if there is no formula, so what should we do? Okay, so we can use U-substitution. Okay, we integrate this using U-substitution because sin and cos are related in terms of derivative. Okay, so when we use U-substitution, we can try U equals to cos theta. Okay, and under U-substitution, after we identify U, we need to differentiate. So from U and variable theta here, when we differentiate, we get du over d theta. We differentiate cos theta equals to negative sin theta. And after that, we need to write d theta as a subject. So we just cross multiply. So we get d theta equals to du over negative sin theta. Right? And after that, we substitute back into this function. Okay? So we have half integration of, we still have numerator sin theta. Our u equals to cos theta. So cos squared theta equals to u squared. And then times, we replace d theta equals to du over negative sin theta. Right? If you make the correct choice of u, we can simplify all terms containing theta. Okay? So from here, we can simplify sin theta and sin theta in denominator here. And then at the same time, we can move out negative sign from integration sign. So we have negative half integration of 1 over u squared du. So from here now, we success write all in terms of variable u and du. No more variable theta. Okay, from here we can integrate. But to integrate 1 over u squared du, first we need to use the properties of indices. We need to write 1 over u squared equals to u to the power of negative half. So now we have negative half integration of u to the power of negative half du. From here, we have n, which is negative 2. So now we have n not equals to negative 1. So we can integrate this using power rule. Okay. Now we integrate with respect to u. Alright. Using power rule, we still have constant negative half in front here. Okay. And then we integrate u to the power of negative 2. Using power rule, we get u to the power of negative 1 over negative 1. And after we done integrate, we put plus c at the back because this is indefinite integral. Alright. Alright, after that, we rearrange negative times negative equals to positive. And then 1 over 2. And then u to the power of negative 1, we can move down. So we get u to the power of positive 1. And to the power of positive 1, we don't need to write. We just write u. Yeah. So from here, after we simplify, we get 1 over 2u plus c. Alright. From the previous slide, we get integration of x over 4 minus x squared bracket to the power of 3 over 2 dx equals to 1 over 2u plus c. And from the previous slide, our u equals to cos 2 theta. So we can write equals to 1 over 2. We replace back u equals to cos theta and then plus c. Alright. And then from reciprocal function, we can write half and then sec theta because 1 over cos theta equals to sec theta and then plus c. Okay. And after that, when we compare from the given question here, we have variable x. But now, after we integrate, we have term containing trigo and with variable theta. Means that we still not finish our solution. Okay. So from here, we need to replace variable theta in terms of variable x. Okay. So we can write half sec theta plus c as equation 1. Okay. And after that, we need to replace theta by x using triangle method. Okay. When we use triangle method, we use step 1. Okay. From x equals to 2 sin theta. And then we write sin theta as a subject. We move to left-hand side. So we get equals to x over 2. From sin theta equals to x over 2, x means opposite and 2 means hypotenuse. So we can draw a right angle triangle with angle theta. Our opposite equals to x. Our hypotenuse equals to 2. And then using Pythagoras theorem, we can find the length of adjacent. Okay. Means hypotenuse squared, 2 squared minus x squared. So we get square root of, and then we have square root symbol for Pythagoras formula. Okay. Square root of 4 minus x squared. Alright. This is our adjacent. Alright. When we compare from the given question here, since 4 minus x squared to the power of 3 over 2 is equivalent to square root of 4 minus x squared bracket cube, means now we get the same term when we compare from this adjacent. Alright? Alright, so means that we take the correct function as x. Okay? So from here means that we choose the correct method. Okay? Means we choose the correct substitution for x. Alright? Alright, so from here, now our goal, we want to replace sec theta in terms of variable x. So before that, we can find cos theta. Okay, cos theta equals to adjacent square root of 4 minus x squared over hypotenuse 2. Okay, and since sec theta is a reciprocal function for cos theta, so to find sec theta, we just exchange numerator and denominator from cos theta. So we get sec theta equals to 2 over square root of 4 minus x squared. And after that, we substitute sec theta into equation 1 here. Okay, and after we substitute, so we get equals to, we still have constant half in front, and then from here, our sec theta equals to 2 over square root of 4 minus x squared. So we replace sec theta here by 2 over square root of 4 minus x squared. Alright, and then plus c here, and after that, we can simplify numerator 2 and denominator 2 here. Then we get the final answer equals to 1 over square root of 4 minus x squared plus c. This is the final answer because now we get the answer in terms of variable x and radical. Okay, so this is logic for the final answer for this question. Alright? Alright, now we look back example 4 for extra explanation. Okay, from integration of x over 4 minus x squared bracket to the power of 3 over 2 dx, we get the final answer 1 over square root of 4 minus x squared plus c when we solve using trigonometric substitution from the previous slide. Okay, right now let's try using integration by U-substitution. Okay, let's say we choose our u equals to 4 minus x squared. Right, why we can try using U-substitution? Because from numerator, we have x to the power of 1. And from denominator, in bracket, we have term containing x squared, or the highest power for this polynomial in bracket equals to 2. Okay, so we can relate with derivative. Okay, so if we can relate with derivative, we can try using U-substitution. Okay, so now let's say our u equals to 4 minus x squared, and when we use U-substitution, we need to differentiate. Okay, du over dx equals to negative 2x, and after that, we write dx as a subject. So we just cross multiply, so we get dx equals to du over negative 2x, right? And after that, we substitute back into the given question here. We have integration of x, we still have x in numerator here, and then we replace the function in bracket equals to u. Okay, because our u equals to 4 minus x squared, and then to the power of 3 over 2 times, we replace dx equals to du over negative 2x. Alright, after that, we can simplify x in numerator and x in denominator. And at the same time, we can move out constant negative half from integration sign. So we have 1 over u to the power of 3 over 2 du. Okay, so to integrate integration of 1 over u to the power of 3 over 2 du, we need to use the properties of indices. Okay, so from here, we have negative half, and then integration of, using properties of indices, we can write this into the form of u to the power of negative 3 over 2 du. Okay, from here, we have term containing u and du, means we can integrate. In this case, we can integrate using power rule, because we have power not equals to negative 1. Alright, so from here, we integrate using power rule, so we still have negative half in front, and then we get 2 the power of negative half. Why the power of negative half? Because negative 3 over 2 plus 1. So we get negative half. And after we integrate, no more integration symbol. And using power rule, we need to over n plus 1. Okay, our n equals to negative 3 over 2, and then plus 1 equals to negative half. Right, and then after we done integrate, we put plus c at the back because now we have indefinite integral. Okay, so we need to put plus c at the back. Okay, and then from here we have times negative half and over negative half. So we can simplify. Okay, so after we simplify, we get u to the power of negative half plus c. And using properties of indices, we can write 1 over u to the power of positive half or square root of u. And then plus c. And after that, we can replace back our u equals to 4 minus x squared. So after we integrate this using U-substitution, we get the final answer equals to 1 over square root of 4 minus x squared plus c. And when we compare with the final answer when we integrate using trigonometric substitution, we compare this, okay? We get the same answer, right? Means that this is also the correct method, right? So we can use U-substitution to integrate this question, okay? If the question does not specify a method for integration, we are free to choose the appropriate method. However, if the question states a method, then we need to use the stated method. Okay? In this case, if we compare between U-substitution and trigo substitution, U-substitution is more easier. Okay? But since the question state to use integration using trigonometric substitution, so in this case, we need to integrate using trigonometric substitution. Alright? Alright, but if the question doesn't state about the method, so we are free to choose which method we want. Alright? Coming up next, integration by parts. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.